Every year, in a convention center most people have never visited, a company holds a conference most people have never heard of. And every year, what gets decided at that conference quietly reshapes the technology you use every single day. This year, it is NVIDIA's GTC 2026, San Jose, California, 30,000 attendees from 190 countries. The keynote streams free on Monday, March 16th at 11 a.m. Pacific at NVIDIA.com. No account, no registration. Anyone can watch. Most people will not. That is fine. That is what this video is for. Here is what you need to know about NVIDIA before we go further. They make the chips, called GPUs, that power most of the world's artificial intelligence. Not some of it. Most of it. Roughly 80 to 90% of all AI training workloads run on NVIDIA hardware. When you talk to a chatbot, ask an AI to summarize something, or get a recommendation on a streaming service, an NVIDIA chip almost certainly processed that request in a data center in a fraction of a second without you knowing. GTC is where NVIDIA tells the world what those chips and systems look like next. And here is the thing most people miss. GTC has evolved into the Super Bowl of AI infrastructure. The chip architecture NVIDIA revealed at last year's conference sent enterprise buyers into multi-billion-dollar purchasing cycles that are still running. What Jensen Huang announces on Monday will ripple through cloud provider strategies, AI startup roadmaps, and corporate IT budgets for the entire following year. This is not a product launch. It is an industry reset. For major announcements are expected. Let's go through each one. Here is a problem most people do not realize they have. Every time you use an AI tool, ChatGPT, Google Gemini, Siri, almost anything you can name, your request leaves your device. It travels to a remote server, gets processed in a data center, and comes back as an answer. Your words, your files, your context, all of it takes a round trip through someone else's infrastructure every single time. The first major expected announcement at GTC 2026 is built to change that. It is called NemoClaw. NemoClaw is an open-source AI agent designed to run locally, on your own machine, without a cloud connection. It can read and organize your files, open and control applications, and execute multi-step workflows entirely on your device. Nothing leaves. Open source means the code is free to use, inspect, and build on. Any developer, at a hospital, a school, a small business, can deploy this without licensing fees or a subscription to a cloud platform. But the shift that matters most is not technical. It is about the relationship between you and your tools. Right now, AI is something you consult. You ask. It answers. You act. 3 steps, and the middle one belongs to someone else's server. NemoClaw removes the middle step. The AI lives where your files live. It works where your work happens. And it does not need permission from a data center to get started. That is a different kind of AI, not smarter, necessarily, but fundamentally more yours. Everything we just described, an AI agent that works locally, fast, on complex tasks, requires a chip powerful enough to run it without a cloud behind it. The second major announcement at GTC 2026 is that chip. It is called Vera Rubin, and it is NVIDIA's next-generation GPU architecture. NVIDIA's current generation is called Blackwell. It is already the most powerful AI chip in commercial use. Every major AI lab and cloud provider in the world is either running on it or waiting to. Vera Rubin is what succeeds it, and the gap between them is not a small step. Vera Rubin is expected to deliver 5 times the AI performance of Blackwell, with up to 288 gigabytes of HBM4 memory, a new, faster memory type that sits directly beside the processor. The closer the memory is to the chip, the less time data spends traveling and the faster everything runs. Why does a chip you will never hold change anything for you? Think about your smartphone. It feels meaningfully faster every few years, not because you started using it differently, but because the hardware underneath improved. The camera, the voice assistant, the speed of everything is downstream of the chip. AI works the same way. When the chips inside the data centers running AI services improve by a factor of 5, the services you use get faster, more capable, and eventually cheaper, without you doing a single thing. The scan reads more accurately. The translation is instantaneous. The local AI agent on your laptop, from Part 2, can finally run without lag. Vera Rubin is what makes the next version of AI possible. Everything we have covered so far lives in software. It runs on a screen. You interact with it through a keyboard or a voice command. The third major announcement area at GTC 2026 is about AI that leaves the screen entirely. NVIDIA is expected to reveal significant updates to two robotics platforms, GR00T and Isaac. GR00T, which stands for Generalist Robot 00 Technology, is NVIDIA's foundation model for humanoid robots. The word foundation is the key one. Instead of training a robot from scratch for a single task, move this box, tighten this bolt. A foundation model gives a robot general-purpose intelligence that can adapt. Show it a new task, and it does not need months of retraining. It reasons about what to do. Isaac is the simulation layer that sits underneath GR00T. Before any physical robot enters a real environment, Isaac trains it inside a simulated one, running millions of scenarios in hours that would take months in the real world. Think of it as a flight simulator. You would not put a pilot in a real aircraft on day one. The same logic applies to a robot learning to navigate a ward, a warehouse floor, or a family kitchen. The industries deploying this now include logistics, manufacturing, elder care, and healthcare. Not pilot programs. Operational systems. The honest timeline for physical AI reaching everyday life is longer than for software. The physical world is messier, less forgiving. But what gets announced at GTC 2026 sets the engineering schedule. Not the dream, the plan. Here is the frame that ties everything together. NVIDIA does not come to GTC to announce products. They come to announce a vision of what AI is becoming. And this year, the vision has 5 layers. At the bottom, energy, the raw power that data centers need to run. NVIDIA announced partnerships this week involving at least 1 gigawatt of computing capacity dedicated to frontier AI training. 1 gigawatt. That is roughly the output of a nuclear power plant, pointed entirely at making AI smarter. Above that, chips. Vera Rubin, the hardware that converts that energy into useful computation. Above that, infrastructure. The data centers, cloud networks, and partnerships that make chip power accessible to the world. Eli Lilly this week announced the most powerful AI computing facility wholly owned by any pharmaceutical company, aimed squarely at accelerating drug discovery. Above that, models. The AI systems themselves, including agent frameworks like NemoClaw, which let models take action in the world rather than just answer questions in a chat window. At the top, applications. The tools regular people actually use, sitting on everything below. Every single layer of that stack has its own ecosystem of jobs, companies, and technologies. What gets announced at GTC determines which tools get built in the next 12 months, how fast AI gets cheaper to access, and which parts of the economy feel different by the end of next year. That is not speculation. Last year's GTC triggered purchasing cycles worth billions of dollars that are still running. This year's will do the same. And you can watch the whole thing unfold for free. Jensen Huang's keynote is Monday, March 16th at 11 a.m. Pacific, streaming live at NVIDIA.com. No registration, no account required. If you want the full build-up, the pre-show starts at 8 a.m. with Perplexity CEO Arvind Srinivas and other industry leaders before Jensen takes the stage. Now you know what GTC is. You know what is being announced today.